Good afternoon. Myself Silky, Assistant Professor, IIMT College of Science and Technology. Today I will give a small session on working of data link layer in networking. Data link layer. In OSI model, the data link layer is the fourth layer from the top and second layer from the bottom. The communication channel that connect adjacent node is known as link. And in order to move datagram from source to destination, that datagram must be moved across the individual ring. The main responsibility of data link layer is to transfer the datagram across the individual link. Data link layer protocol defines the format of packet exchange across the node as well as the actions such as error detection, retransmission, flow control, and random access. The data link layer protocol are Ethernet token ring, FDDI, that is Fiber Distributed Data Interface. The FDDI is a set of data transfer method meeting with ISO standards. This transmission occur on fiber optics LAN extended up to 200 km. And second is PPP, that is point-to-point protocol. Is a TCP protocol that is used to connect one computer system to another. Computer PPP, a point-to-point protocol to communicate over the telephone network or internet. PPP point-to-point was often used for dial-up connection. Nowadays, it is still used for DSL with point-to-point of Ethernet, and our ATM was also used point-to-point Ethernet service. And the important characteristics of data link layer is that datagram must be handled by link layer protocol on different link in a path. For example, the data is handled by Ethernet on first link point-to-point onto second link. Services of data link layer. First is framing and link across. Second is reliable delivery. Third is flow control. Fourth is error detection. Fifth is error correction. And last one is the half duplex and full duplex communication. First is framing and link access. In framing and link access, data link layer protocol encapsulate each network frame with link layer before the transmission across the network. A frame consists of data field in which layer datagram is inserted and number of data field is. It is specific that structure of frame as well as channel across the protocol by which frame is transmitted over the link. Data delivery. In data link layer, provide a reliable delivery service, that is, transmit the network layer datagram without any error. A reliable delivery service is accomplished with transmission, acknowledgement. A data link layer mainly provides the reliable delivery service over the links as they have higher error rate and they can be corrected locally, link at which error occur rather than forcing the retransmit of the data. Now flow control. In flow control, a receiving node can receive the frame at a faster rate than it can be processed the frame. Without flow control, the receiver buffer can overflow and frame get lost. To overcome this problem, the data link layer uses flow control to prevent the sending node on one side of the link from over to receiving node to another side of the link. Now, error detection. Error can be introduced by signal, and that is authentication or noise. In data link layer, protocol provide a mechanism to detect one or more errors. This is achieved by adding error detection bit in the frame, and then the receiving node can perform the error check. Error correction. Error correction is similar to the error detection, except that the receiving node not only detect the error but also determine where the error has occurred in the frame, because there the one error detection bit is added to the each frame, and the receiver will be find the error and detect the error. Now last is half duplex and full duplex. In full duplex mode, both node can transmit the data at a same time. And in half duplex mode, only one node can be transmit the data at a same time. But nowadays we use the full duplex because at a time we send the data and we also at the receive the data. When data transmitted from one device to another, the system does not guarantee whether the data received by device is identical to the data transmitted by another device. An error is a situation where the message received at receiver end is not identical to message transmitted. There are type of error. Error can be classified into two types: single bit error and second is burst error. In single bit error, only one bit of given data unit is changed from 1 to 0 or from 0 to 1. In our figure, the message is sent is corrupted as a single bit, that is 0 bit changed with 1. In single bit does not appear more likely in serial data transmission. For example, a sender sends the data at 10 Mbps speed. This means that the last bit only for 1s and the single bit error to be occurred. A noise must be more than 1s bit. In single bit error mainly occur in parallel data, that is full duplex communication and full duplex transmission. Um, for example, if eight wire are used to send the 8 bit of byte at the same time, if the one wire is noisy, then the single bit is corrupted per rate. That is a single bit of error. Now, burst error. Two or more bits are changed from the one as 1 to 0 and 0 to 1, that is known as burst error. The burst error is determined from the first corrupted bit to last corrupted bit. The duration of noise is burst error is more than the duration of noise in single bit. The burst bit error are most likely to be occurred in serial data transmission, that is half duplex transmission. Now, error detection technique. The most popular error detection techniques are, they are basically four. First is single parity check. Second is two-dimensional parity check. Third is checksum. And last one is CRC, that is cyclic redundancy check. What is single parity check? The single parity check is a simple mechanism and inexpensive to detect the error. In this technique, a redundant bit is also known as a parity bit, which is append to the end of the data unit so that the number of ones become even. Therefore, the total number of transmitted bit would be 9. If the number of ones bit is odd, then the parity bit is 1. Then the append, if the number of ones bit is even, then the parity bit will be 0. It is append at the end of the data unit. You can show in diagram. At the receiving end, the parity bit is calculated from the receiver end and compared with the receiver party bit. This technique is generate total number of ones is even and it is known as even parity check. It we also say that it is an even parity check. In this diagram, we see the sender sent the message, and one is complement should be added and transmitted over the medium. Then the after the transmission, then the it's converted into added the 1s bit to +1 and compute the parity bit. Then the if the data is ordinate is even, then the accepted by the receiver. If it's not, then the rejected by the receiver. This is the single parity check. Now, what is the draw? And then what is the drawback of single parity check? It can only detect single bit error, which is are very rare. If two bit are interchanged, then it is can't be detected by the single parity check error. Then we that come two-dimensional parity check. The performance can be improved by the two-dimensional parity check, which organize the data in the form of table. The parity check bits are computed for each row, which is equivalent to the single parity check. In two-dimensional parity check, a block of bit is divided into row, and the redundant row bit will be added to the whole block. At the receiver end, the parity bits are compared with the parity bits computed from the receiver data. This is the original message, and it is transmitted and framing, and after the framing, transmitted over the network. We can see that then the whole week is complement with 1s, and then travel on the transmission medium. After the receiving, the whole bit will be combined and then +1, and then we check the data is original or not. The drawback of two-dimensional parity check: if the two bit is one data unit are corrupted, and the two bit is exactly same position in another data unit are also corrupted, then two bit parity checker will not able to find the detect the error and that situation. In this situation, the two bit parity check will be not used there. Then we use the checksum method to find the error. This technique cannot be used to detect 4-bit error or more in some cases. Now, what is checksum? A checksum is error detecting technique is based on the concept of redundancy. And in checksum, there is a two type: checksum generator and checksum checker. At first, we understand what is checksum generator. A checksum generator at the sending side, the checksum generator subdivided the data into equal segment of n bit of each, and all these segments are added together by one is complement of arithmetic. The sum is complemented and append to the original data. It is known as checksum field. The extended data is transmitted across the network. Now, what is checksum checker? After the checksum generator, the checksum is verified at the receiver side. The receiver subdivided the incoming data into equal segment of n bit of each, and all these segments are added together, then its sum is complemented. If the complemented sum is 0, then the data is accepted, otherwise data will be rejected. The last one is CRC, that is cyclic redundancy check. And nowadays we use CRC and CRC method for checking the data, for detecting the error in a bit and to correct the data. CRC is a redundancy error technique used to determine the error. Following are the steps used in CRC error detection. In CRC technique, a string of n bit, one's complement is append to data unit, and n number is less than the number of bit in predefined number, then the known as the division is n plus 1 bit. In secondly, the newly extended data is divided by division using the process is known as binary division. The remainder generated from the division is known as CRC remainder. CRC remainder replaced with 0s complement at 0s bit at the end of original data. This newly generated unit is sent to the receiver. The receiver received the data followed by the CRC remainder. The receiver will be treated this whole unit as a single unit and it is divided by same divisor that was used to find the CRC remainder. And this remainder, CRC remainder theorem, is applied to whole bit. And at first we divide the data into bit and then apply the CRC remainder theorem, and that is binary division to whole bit. And after that, the receiver will be generate the new received data and matched with the remainder. Then it will be verified. Then the data should be received. And if the error is not verified, then the data is error is detected. Then again move to the CRC remainder. If remainder again matched with the 0 and receiver replace the append at the end of original data, this is the then the data should be received. Then the receiver verified it that the error should be that no error should be found at the that of data. This is the CRC theorem, and nowadays we using the CRC method for error detection in our networking. They are the four basically error detection technique that are explained there. Okay, thank you. पता नहीं मैम कितने मिनट का बना, अब जितने का बना उतना ही भेज दूंगी। पीपीटी मैंने छोटा ही बनाया था, मैंने देखा ही नहीं था उतना ही बनाया था। हाँ भेज दूंगी।